Good evening, everyone. Welcome back to another one of our revision mat guides. This is our final one for this summer, so I hope they benefited you in some way, shape, or form. And as is our last one, we've kind of homed in on different topics, and this one is got a lot more area, volume, surface area in this revision mat. So let's jump onto our iPad and make sure that everything is ready for us to go. Yep, everything's ready. Let's jump on and try to solve some of these questions. So the first one, work out the volume of a cuboid with the below net. So we've got a net below. Calculate the perimeter of the net is our second question. So the volume of this cuboid, the below net, means I've got to kind of like imagine or even draw out this cuboid, something like that. Very rough sketch. And I can see that it's 7.4 by 3.1 by 5. So 7.4 centimeters by 3.1 by 5 centimeters is what I'm looking at here. And so with that in mind, I'm going to try to work out the surface area. I think it was, no, it says the volume, excuse me, the volume of this cuboid, right? And so in order for me to work out the volume, is going to be trying to work out a cross section and then multiplying through. So I might start off by multiplying to work out this cross section here. 3.1 times 7.4. I could use something like this, column multiplication. I could think of it as 31 times 74 and then put my place value in as well, by my decimal point, excuse me, for the place value. So if it's 31 times 74, 4 times 1 is 4, 4 times 3 is 12, and so you've got in the tens column now, 7 times 1 is 7, 7 times 3 is 21, so you've got something like this. 2294. Now, as it's 3.1 times 7.4, there's two ways I can think of this. In the actual question itself, so let me highlight the question. In the question itself, there are let me do that again. There are 1 and 2. There's 2 decimal places in my question. Digits after the decimal place in my question. So there will be 2 digits after the decimal place in my answer as well. Okay, so it'll be 22.94. Another way to think about it is the fact that, well, 7.4 is quite close to 7, 3.1 is quite close to 3, 7 times 3 is 21, so my answer should be around 21. 22.94 is the only number that I can place a decimal with these digits that's close to 21. Okay, so 22.94. So the next step, okay, so I've worked out the cross section, and so the next step is for us to work out the volume. The volume is going to be 22.94 times 5. I know 22.94 times 10 is 229.4. And so 229.4 divided by 2 is another way I could work this out instead of multiplying by 5. 229.4 divided by 2 is going to be, that's going to be 1. That's going to be 4 and 7.7, 114.7 cubic centimeters. 114.7 cubic centimeters is our volume for A. Okay, for B, calculate the perimeter of the net. It's a bit more tricky, this one. You've got 7.4. So what we have to do is we have to add quite a few of these together, right? So let's see how we can do that in an efficient way. So let me just get rid of all of this, and we've got a bit more space to write with. And so here, I'm going to be adding up these lengths. So what I tend to do is I tend to, somehow show that I've added these together by making a mark or putting a tick, so I don't really have to add them again by accident. Okay, so I've got 7.4, add 3.1, add this is 5.0, add this is 3.1, this is 3.1. And then I've got 5 again. And then I've got this is 7.4, this is 3.1. So I have to add another 7.4, 3.1. So I've done that. Then I've got to add another. Then I've got to add. I can continue to do that. And I keep going on. I've added another 5. Add another 3.1. Add another 3.1 here. Add 5, 3.1. Add 5. Add 3.1. And I've got another 3.1 here as well. And I can see that from here, I've got 1, 2, 3, 4, 5, 6, 7, 8 lots of 3.1s. So 8 times 3.1. Add, I've got 7.4, 7.4, 2 7.4s. So 2 times 7.4, oops. 2 times 7.4. I've got 1, 2, 3, 4 times 5, and that would give me the perimeter of my net. Let's see if how do I check if that's going to be reasonable? I've got 8 plus 2 is 10 plus I've got 14 sides here that I counted for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so I've got 14 sides there as well. So it seems like I'm on the right track. Okay, so 8 times 3, 8, 16, 24. 24, 8 times 0.1 is 0.8, so 24.8 here. 2 times 7.4, 2 times 7.5 is 15, so 2 times 7.4 is going to be 14.8, and 4 times 5 is 20, and so I can add that together. So instead of using column addition to add all of these together, that would take me quite a bit of time, right? That would take a lot of children a lot of time, and they might make mistakes. It'd be more sensible for us to use multiplication and then add them together. So 14.8 plus 24.8 is going to be 28, 38.8, 39.6. 39.6 add 10 is 49.6, and another 10 is 59.6. So 59.6 centimeters is the perimeter, and that's our answer for B. So that took a bit more time, but thinking about consistency and thinking about the most efficient method, I would make sure that I have something like this rather than adding them all using one column addition column, and that would take a lot more time and more likely to make mistakes as well. Question 2. Mary travels at a speed of 24 kilometers per hour for 1 hour and 12 minutes on her bicycle. How far does Mary travel? So this is really important that we understand what kilometers per hour means, right? Or miles per hour, whatever they use. This just means that Mary travels, for every hour, she travels 24 kilometers. So for every hour she travels 24 kilometers, that means, what does that mean? It means that in 1 hour she travels 24 kilometers, right? So she's traveled for 1 hour, so we know that's going to be 24 kilometers because she travels 24 kilometers per hour. And she's traveled for 12 minutes, not 20 minutes, 12 minutes. 12 out of 60 minutes is going to be 12, 24, 36, 48, 48, 60. That's going to be, is that a fifth? 12, 24 times 2 is going to be 48. That's going to be 4 so far. And then add another 12 is going to be 60, right? So that's going to be 1/5 of an hour. Okay, so that's a fifth of an hour. How far does Mary travel? Well, she traveled a fifth of an hour, which is 12 minutes. And she traveled for 1 hour. So she traveled for 24 kilometers plus a fifth of an hour's worth of travel means a fifth of 24. So 24 plus 24 divided by 5. Well, 24 divided by 10 is 2.4. 24 divided by 5 must be 4.8. So it must be 24 plus 4.8 kilometers, which is going to be 28.8 kilometers altogether. 28.8 kilometers altogether is how far she's traveled in that time. So the key thing here is for speed, distance, and time questions, firstly, we need to understand what it means by kilometers per hour and what repercussions there is for that. Secondly, Where it says per hour and we've got minutes, we got to transfer those minutes into, or not transfer, but convert rather those minutes into hours. So 12 minutes out of 60 minutes is a fifth of an hour. And so we can then think about, oh, a fifth of an hour, she's traveled a fifth of an hour. So she hasn't traveled whole an hour, that would have been 24 kilometers. She traveled a fifth of that, which is 4.8 kilometers in this case. So key thing about speed, distance, time is understanding. Most of the questions that we go through in terms of these challenging topics, if there's a lack of understanding, there's going to be a lack of being able to answer these questions efficiently because we haven't understood the question or the topic itself. Question 3, what is the area of the largest face of the triangular prism below? So A, let's work out the area of the largest face. I can see that the bottom face, the bottom one's going to be 3 times 7 centimeters. The one behind is going to be, what's that going to be? It's going to be 4 times 7. And this one here is going to be a 5 times 7. And so 5 times 7 is going to be larger than 4 times 7 and 3 times 7. So for A, it's just going to be a case of working out what 5 times 7 is, which is 35 square centimeters. That's going to be the area of the largest face. The triangles are going to be smaller than me, 4 times 3 divided by 2, for example. So I know it's not going to be those triangles as the largest face. B, work out the volume of the prism. So with the volume of the prism, we've got to make sure we know that we have this triangle, rather they said in American accent, this triangle as the cross section. So if I cut this anywhere, it's still going to have a triangle here. That's how I know it's a cross section. So this triangle, the area of this triangle is going to be 4 times 3 divided by 2, which is 6 square centimeters. The area of this triangle is 6 square centimeters. This triangle goes on for 7 centimeters, so it'll be 6 square centimeters times 7 centimeters, which will give us the volume, which is what we're looking for. So the volume, 6 times 6 is 36, 6 times 7 is 42. 42 cubic centimeters is the volume for this shape. So let's move on to question 4. An aeroplane is 69.79 meters long and its wingspan is 64.8 meters. So if you think about an aeroplane, quickly draw an aeroplane here, something like this. This is really poor drawing of an aeroplane, something like that. Okay, really bad. So it's saying that length from here all the way here, that's 69.79 meters. The wingspan, which is this one end of the wing to the other end of the wing, is 64.8 meters. What is the difference between the aeroplane's length and wingspan? So we're doing 69.79, take away 64.80, and we're subtracting. So 9 take away 0, or other way around. Yeah, 9 take away 0, excuse me, is going to be 9. And then we've got 17 take away 8, so I mean 9 again. 8 take away 4 is going to be a 4. 6 take away 6 is 0, so 4.99. So for A, 4.99 meters is the difference between the length and the wingspan. B, to the nearest 10 centimeters, what is the sum of the wingspan and length of the aeroplane? The sum, so we're adding them together, 64.8 plus 69.79. If we add this together, we get 9, we get 15, we get 4, and we get 13. So we've got 134.59 to the nearest. That's in meters, which in centimeters, we're going to multiply by 100, is 13459. 13,459 is to the nearest 10 centimeters, so it'll be 13,460 centimeters as our sum in centimeters to the nearest 10 centimeter. Okay, question 5. A tile measures 0.5 by 0.5 meters and comes in packs that covers an area of 1.75 square meters. So a bit of information here that we need to understand. Firstly, if it's a 0.5 by 0.5 meter tile, the area that it covers will be 0.5 times 0.5. 5 times 5 is 25. 0.5 times 0.5, 0.25 square meters. So this tile covers 0.25 square meters, comes in packs of 1.75 square meters. 1.75 divided by 0.25 gives us, what does that give us? 7, right? 0.25, 0.5, 0.75, 1 whole, 1.25, 1.5, and 1.75. Yeah, 7. So that means there will be 7 tiles per pack. That's what we've just worked out from that first initial part of our question. A, how many packs are needed to cover a room with a floor area of 11.25 square meters? Now we know each pack comes with 1.75 square meter worth of tiles. And so if I start to think about this, 1.75 is same as 1 3/4 of a meter. And so I could do 11 1/4, which is 11.25. This is 11 1/4 divided by 1 3/4. I could do that, but that means quite a bit of work, right? I've got to convert this into improper fractions. 11 times 4 is 44 plus 1 is 45/4 divided by 4 plus 3 is 7/4. I have to do this, which is equal to 45 over 4 times 4 over 7. And then I can cancel this out. And then I can do 45 times 1 divided by 45 over 7. So 45 over 7, and that will give me an answer, how many packs I need, right? I could do that, which means I would need 7 packs, because 7 times 7 is 49. And so I'm going to need, it's going to be a bit less than 7, but I'm going to need that extra pack anyway, so it makes 49, right, altogether, tiles that I'll get. That's one way. That might be a bit longer, because I've got to do a lot of fraction work there. Going to be very confident in my fractions, which I should be by this stage. But is there a more efficient method is the question that I'm asking myself. So I would think, well, I know 1.75 is how much is in each tile, each pack, sorry. If I have 2 packs, that'll be 1.75 add 1.75. That's going to be 0, 7, 14, 15, and 3. So every 2 packs, I cover 3.5 square meters. That means 4 packs is going to be 7 square meters. 6 packs is going to be 10.5 square meters. I'm just adding 3.5 multiple of 3.5, 3.5, 7, 10.5. And so I'm going to need 1 more pack, 10.5, add 1.75 is going to be 11.25, 12.25. And so I'm going to need, this is 6 packs, 10.5. Another pack will give me 12.25. 10.5 is not going to be enough because I've got 11.25 to cover. So I'm going to need 7 packs for the first answer. Now I've got quite a lot of working out here. Remember, I've shown 2 different strategies here. The first one, I've done it really quickly, but that's going to require quite a lot of technical work. And some children are going to forget how to do some of those parts or will not be as confident and therefore more likely to make mistakes. Here, I've just added 2 decimals, which gave me 3.5, which is a nice number to work with. And then I could easily work on from there to work out the question, which was 7. So part B is our next question. And we'll go through that now. Just clean this up. And we've got a bit more space. Right, so if you have any questions, I know you're watching this maybe recorded, maybe live, when we post this on our 11 plus group. But if you have any questions, feel free to ask away. If you're not sure about anything, do ask. I'm sure if I'm not there, others will be able to support you. I'll be away for a bit in the next few days. I'll be going abroad, so I won't be on as much. But happy to answer the questions when I come back. A room needs 10 packs. What is the maximum floor area of the room to nearest meter? Okay, a bit more complicated, this one. If it needs 10 packs, 10 times 1.75 means it's 17.5 square meter coverage. That means that those 10 packs can cover up to 17.5 square meters. It says, what is the maximum floor area of the room to nearest meter? Okay, so the floor area means I don't know the length or the of the width of the floor, but the area can't be more than 17.5, can it? It can't be more than 17.5 square meters because otherwise you would need more than 10 packs. So 17.49, I suppose, right, is pretty much the largest amount we can have. And 17.49 to the nearest meter, right, is going to be 17 meters. So part B, 17 meters, square meters, is to the nearest meter is what the floor area could be, okay? Because otherwise it would be too much. It would be the next meter, 18 meters. And if it's 18 meters, that can't work because obviously 10 packs can only cover 17.5 square meters. Okay, question 6. There are 900 pupils at a school. There are 80 more girls than boys. How many boys are there? So you've got 900 pupils, 80 more. So we like to use bar modeling. You can use algebra for this as well. We use both. So we don't just stick to bar modeling. We use both. First, initially with children, we start to use bar modeling because it makes much more sense for them. And then we introduce algebra and replace the bars with x's or whatever terms that we have. And therefore, it makes much more sense for children. So let me give an example of that. There are 900 people at a school. There are 80 more girls than boys. So if we've got girls here, there are 80 more girls. So if this is the boys, if that's the boys, right? Let me do that again. If that's the boys, which is going to be about here, the girls are not the same as the boys, which would be here, but there's 80 more. Right, there's 80 more girls than boys. Does that make sense? The bar shows there's 80 more than the boys. Altogether, all of this is 900. There are 900 pupils. So with that in mind, if I subtract this 80 from the 900, I'm left with 900 take away 80. I'm left with 820. These two elements, these two parts are equal. I'm left with two equal parts, two equal bars that are equal to 820. And so each part must be 820 divided by 2, 410. Each part must be 410, worth 410. Why? Because that must mean that there are 80 more girls. 80 plus 410 is 490. And there are still 410 boys. 490 is 80 more than 410. Add the 410 is going to be 400 plus 400, 800, 9 plus 10 is 100. 800 plus 100 is 900. So there are 900 altogether. There are 80 more girls than boys. Question is, how many boys are there? There are 410 boys in this school. So let me know if that makes sense. Now with algebra, we would do exactly the same thing, right? We would do, there are X boys, right? Boys. X plus 80 girls. Altogether, X plus 80 is equal to 900. What does that mean? It means that 2x plus 80, 2x plus 80 equals 900. What did you do here? We subtracted the 80 first. 2x is equal to 900 take away 80. We'll take away 80 on both sides. Is equal to 820. X is equal to half of that, divided by 2 on both sides, 410. X is the number of boys, so we've got 410. That's me really quick going through it, bit messy there, lack of space, but generally that's how we'd go through using algebra. Same steps in terms of subtraction, dividing by 2 with the bar model approach. Bar model approach for most children makes a lot more sense. That allows us to go to algebra understanding algebra, not just trying to make them memorize, but to understand algebra is the goal, because you're setting your children up for the rest of their lives, right? In maths, in secondary school. We want them to have good habits from the start. To understand is good habit. Not to understand and memorize, not the greatest habit, okay? So bear that in mind. Question 7, 8, and 9. 7 is a bit more challenging. So we need to remember a few things. So this is a similar question that came up in the CSSE exam. I think it was 2021 or 22 paper. From what I can recall, is very similar. Okay, and we want to kind of go through this question with you because I think there's a more elegant way of doing this, because there's two options here. One, we do 3 times 4x, which is 4, 8, 12, 12x. And then we can do the area of this is going to be 2x times x plus 2. And that's equal to the 12x. We can do something like that, okay? Now, that requires our children to know we can divide both sides by 2x, and then you've got x plus 2 equals 12, divided by 2 is 6, x divided by x is 1, and so you've got x plus 2 is 6, x equals 4, because 4 plus 2 is 6. And that is challenging, because we're talking about children most of the times will expand here. They will expand here, and that what that means, if they did expand here, what that would mean is they have quadratics. Quadratics we teach at a lot later stage, right? 2x times x, 2x squared plus 2x times 2, which is 4x. So you're saying 2x squared plus 4x equals 12x, and that is quite a challenging prospect for most children. Okay, at this age, that is, because that's something we look at end of key stage 3, even key stage 4. So we don't want to do that. So what we need to kind of reflect on is our understanding of area and equal area as well. If the area of below rectangles are equal, work out x. That means, if you think about it, if we have, let's take a basic example. If we have two shapes like this, 2 rectangles like this, and we say this is 4 centimeters, right? And we've doubled this to 8 centimeters, right? This is 6 centimeters, let's say 6 centimeters. That's 6 centimeters, and they're both of the same area. Then that must mean we have to halve this. That becomes 3 centimeters, because 8, 16, 24, this would be 24 square centimeters. 6 times 4 is 24 square centimeters. So what did we do? We multiplied one side by 2, but then we had to divide the other side by 2, and that will give us the length of the rectangles for us to have the same area. So having the same area means if you multiply one side of a rectangle by 2 for the other rectangle to have the same area, the other length must be half of the previous shape's length. So we've got 6, 3, 4, 8. One's half, one's double. Similarly, if it says here, work out x, we know 2x times 2 is 4x, right? So we have to think about the fact that we've multiplied this by 2 to get 4x, or if we do the other way around, might be more easy to understand, we have to 4x divided by 2 is 2x. So we have to realize that this x plus 2 must be 3 times 2 is 6. This must be equal to 6 because we've halved this. We know this is 3, so this must be doubled here, which is 6. And so x plus 2 equals 6 is something that we already had using this method. But in our second method, we're just using logic. We're using our understanding of area to get to x equals 4. So x equals to 4 here. Let's see if it's right. If it's 4, then this is 16. 4 times 4 is 16. This length is 16. Let's say centimeters. This is 3 centimeters. 3 times 16 is going to be sort of 18 plus 30. It's going to be 30 plus 18 is going to be 48. So it's going to be 48 square centimeters here. If x is 4, this is 8, right? And this is going to be 4 plus 2 is 6. And so remember what we said? 16, 8. 8 is half of 16. 6 is double 3. So 6 times 8 is also 48 square centimeters. And therefore we have the same area. And it's worked out. X equals to 4. So hopefully that made sense. Hopefully that can help you if you come across questions with area again like this. When we're thinking about area, we can double one side, then halve the other side, and you still have the same area, okay? Going through our penultimate question, question 8, I realized that we might have missed out on one extremely important part, which is this length. So you might not have been able to solve this question because there was a length missing, which is 8 centimeters. So here we've got a L-shaped prism, which we're going to work out the surface area. I've labeled each face 1 to 8 so that it's a bit easier for us to solve. Okay, so we're going to work out the surface area for each of these. So firstly, let's look at face 1, which is a 5 by 15 centimeter face, which gives us 75 square centimeter area. 2 is going to be a 15 by, well, we know this length is 8, and so we need to work out what this length is. If this is 20, that must be 12, so it would be a 12 by 15 centimeter rectangle. And so 10 times 15 is 150, 2 times 15 is 30, so that means it's going to be 180 square centimeters. Third face is going to be a 15 by, what length is this? Let's see, if that's 16, that's 5. That must mean this is 11, so it'd be 11 by 15. 10 times 15 is 150, so one more 15 would be 165 square centimeters. That's face 3. Face 4 is going to be an 8 by 15. And so 8 times 15, 8 times 10 times 8 times 15, or 8 times 10 is 80. 8 times 5 is 40. And so 80 plus 40 is 120 square centimeters. Face 5, if I can find it, here we are. Face 5 here is going to be a 16 by 15 square centimeters. How can I do this quickly? Let's see. 10 times 16 is 160. 5 times 16 must be 40. 160 plus 40 is 240 square centimeters. Say face 6 is going to be 20 by 15. That's a bit easier. 20 by 15. 2 times 15 is 30. 20 times 15 must be 300 square centimeters. 7 and 8 are the same, right? So 7 and 8 is this L shape. So 7 and 8 are the same. So if I can work out this L shape, area of this L shape, that would make my life easier. I know this is 20 centimeters. This is 16 centimeters. This is 5 centimeters. This is 8 centimeters. Therefore, this must be 11 centimeters. This must be 12 centimeters. One thing I can do is 20 times 16 is 320 square centimeters. And I can take away, that's going to give me the shape, this whole rectangle. Okay. And so what I need to do is subtract this section, which is 11 by 12. So 11 times 12. 12 times 12 is 144. 11 times 12 is 12 less than that. 144 take away 12 is going to be 132 square centimeters. And so I have to take away 132 from 320. And therefore I get, well, it's 120. That's going to be 200. Take away another 12. It's going to be 188 square centimeters. And so this is 188 square centimeters. And this is also 188 square centimeters because it's just behind, this L shape is behind here. And so we've got all of these now to add up. Okay, so if we add all of that up, what do we get? Let's make some space here. I'll get rid of this. So we've got a bit more space for us to add up and make sure we're doing it right. So once we get rid of that, let's see what we've got. Are there any pairs that make my life a bit easier? 300 at 240 is 540, plus 120, 560, 660. 660 so far. 660 plus 80 is going to be 740. Plus 100 is 840. So you've got 840 so far. So I can do 840. Add the 70. Okay, so I've got 840 of all of that. 165 add 5 is 170. Add another 70 is 240. So that's 240. So we're going to add 240 to that. And then we've just got 180 add 188. Sorry, 188 add another 188. And that will make my life a bit easier. 8 add 8 is 16. 4 add 4 is 8. 8 add 8 add 8. 8, 16, 24, 25. And I've got a 2 here. 8 add 2 is 10. 10 plus 14. Sorry, 10 plus 4, sorry, is 14. So 1,456. So the surface area is 1,456 square centimeters here. And that's our surface area. So we're going to move on now to question 9, our final question. Final question is one where we look at inverse proportionality or working together questions as well. We've looked at this before in the past in our Singapore Maths Academy Facebook Lives. So have a look at on our Facebook page to see some other questions that we've gone through similar to this. And in order for us to do this, we have to have some parity in terms of the hours or anything that they've given us, some parity between Adam and Mary and individually as well. So here we've got Adam plus Mary can paint one room in 4 hours. Okay, but Adam on his own, so when they work together, one room 4 hours. Adam on his own can paint one room in 10 hours. There are a different number of hours here, right? And so it would be nice for us to know how many rooms Adam and Mary can paint in the same amount of hours. So 4 and 10, I know 20 can be divisible by 4 and 10. So I'm going to find out Adam and Mary in 20 hours, they can paint 4 times 5 is 20. So they can paint 5 rooms together. 5 rooms in 20 hours, Adam and Mary. Adam on his own, though, can paint, or 10 times 2 is 20 hours. So he can paint 2 rooms, because it takes 10 hours per room. 20 hours would be 2 rooms, right? So he can paint 2 rooms in 20 hours, right? 20 hours, 2 rooms. So now I can see that in 20 hours, Adam and Mary together can paint they can paint 5 rooms in 20 hours. Adam on his own paints 2 rooms in 20 hours. That must mean Mary in 20 hours must be able to paint 3 rooms by herself. Why is that, you might ask? Well, 3 rooms add the 2 rooms when they're working together makes the 5 rooms. So in 20 hours, Mary must be able to make 3 rooms. So it says here, if Adam requires 10 hours to paint a room alone, how many hours does Mary take to paint the room? So this is 3 rooms. Mary takes 20 hours to paint 3 rooms. So each room must be 20 over 3. And so that's going to be 6, 12, 18. That's going to be 6 hours. And 6, 12, 18, 2/3 of an hour. 6 and 2/3 of an hour. But it says leave your answer in hours and minutes. Well, 6 hours is in hours. 2/3 of an hour, 20, 40, 60 is 20 minutes. So it's 6 hours and 20 minutes. So hopefully you found this helpful. These solutions are freely available on our Facebook page, as well as the 11 Plus group, as well as our YouTube page as well. If you need any other questions answered from this page, please leave us a message and we'll try our best to answer those questions. If you have any tuition needs, please let us know, and we would love to hear from you and support your child in the 11 Plus needs. Remember, we are experts in 11 Plus maths, especially focusing on CSSE maths and independent school exams as well. Apart from that, thank you so much for taking part in our 4 revision mats that we've published this summer holidays. We hope that they've helped you and your children to prepare for CSSE, and our solutions specially gave you another idea, I suppose, another solution, another strategy for you to work on if your child is having problems with the strategy that you've taught them. Thank you so much for your help, and I'll leave it there. Take care, everyone. Bye.